So, in the previous experiment, it was demonstrated that it required 4 units of energy to stretch the rubber band twice as much. In this experiment, we're going to check whether or not it requires 9 units of energy to stretch it 3 times as much. First, I will drop the pendulum with 1 velocity, and then 3 times the velocity, and see whether or not it stretches 3 times as much.
Okay, velocity check for the 1 velocity. Set the timer on, pull it backwards, and now I have to reset it. Right, let it go. Memory 177, reset it. Let it go. Memory 178, reset. Let it go. Memory 178, one final time. 178, there we go. That's the 1 velocity.
As can be seen, the maximum stretch reaches the 1.7 centimeter mark for the 1 velocity drop.
Okay, velocity check for 3 times the velocity. Pull it backwards. Have to zero it. Release it. Memory 60. Should be 59 in a bit, ideally. 59. Again. 59. One last try. Okay. 59. All right, perfect.
As can be seen, the maximum stretch just seemed to reach the 5 centimeter mark. The 1 velocity drop gave us 1.7 centimeters. This means that this is 2.9 times as much stretch instead of 3 times as much stretch. So not perfect, but pretty close.
I know it's pretty difficult to see, but the distance between the release point and the rubber band is always going to be 6 centimeters. That's the one, it's going to be the 1 unit of energy, right? All right.
So in every case, I'm going to make sure that the distance between the rubber band and the release point is always going to be 6 centimeters. In this way, we can guarantee that it will always be 1 unit of energy that will be delivered to the rubber band. All right, so now, just like in the previous video, the rubber band is now pre-stretched at the location of the maximum stretch of the 1 velocity drop, which was 1.7 centimeters. Again, I made sure that the distance between rubber band and release point is still 6 centimeters. So now I will drop the pendulum, thereby giving it another 1 unit of energy. It's important to note that draft science believes that if we now add another unit of energy, the amount of stretch will be doubled. However, conventional science predicts that it will only stretch 1.41 times further. As can be seen, the maximum stretch is close to 2.4 centimeters. Now, what is 2.4 divided by 1.7? Yes, that's right. The answer is 1.41. We have a perfect result, people. All right, and so we continue. This time the rubber band is pre-stretched at the 2.4 centimeter location, and we will once again add another unit of energy. The maximum stretch is 3 centimeters. The prediction is 1.7 times the square root of 3, which is 2.94. That's very close, only half a millimeter of difference. Continuing, the rubber band is now pre-stretched at the 3 centimeter mark. Let's add another unit of energy. The maximum stretch is 3.5 centimeters. The prediction is 1.7 times the square root of 4, which is 3.4. That's pretty close. So, once again, by now, it is demonstrated that it requires 4 units of energy to stretch the rubber band twice as much or to go twice as fast. Yet another coincidence? Continuing, the rubber band is now pre-stretched at 3.5 centimeters. Let's give it another unit of energy. The maximum stretch is close to 3.8 centimeters. The prediction is 1.7 times the square root of 5, which is 3.8. That's a perfect result. Continuing, the rubber band is now pre-stretched at the 3.8 centimeter mark. At this point, I had to tape a little box to the speaker because I needed something that could fit between the poles that hold the rubber band to keep the distance between rubber band and release point the same. The maximum stretch is close to 4.3 centimeters. The prediction is 1.7 times the square root of 6, which is 4.16. So there is a small difference. The rubber band is now pre-stretched at 4.3 centimeters. Let's add another unit of energy. The maximum stretch is 4.7 centimeters. The prediction is 1.7 centimeters times the square root of 7, which is 4.5. So the difference is 2 millimeters. From now on, the margin of error is becoming slightly bigger. The rubber band is now pre-stretched at 4.7 centimeters. And here we finally are. We have reached the 5 centimeter mark, which was the maximum stretch when it was dropped with 3 times the velocity. Conclusion: in this experiment, it required 8 units of energy to stretch the rubber band close to 3 times as much. Let's remember that draft science predicts that it only requires 3 units of energy to go 3 times as fast. The results are much closer to the kinetic energy predictions than to the momentum is energy predictions. Let those excuses roll in.